Okay, so let's start out with this first problem. Suppose that 3 minus I and 2i are roots of a fourth order polynomial equation. Find A3, A2, A1, and A0. So let me just refer you to the problem that was assigned that was similar. It's right here. It says, well, you can read this, exercise 2.5.3. All right, so what does this mean? If these are roots of the polynomial equation, that means that z minus 3 minus I is a factor of the polynomial. Also, I know that z minus 2i is a factor. And we know that the complex conjugates are also roots. So z minus 3 plus I is a factor, as well as z plus 2i. Now, if you multiply these out, then you'll get the answer. I suggest you do it this way: z minus 3 minus I times z minus 3 plus I times z minus 2i times z plus 2i. Now, these two here are actually difference of squares. It's of the form a minus b times a plus b. And the result of such a form is always a squared plus b squared, so it's going to be, I'm sorry, a squared minus b squared, so it's going to be z squared minus 2i squared. But 2i squared is negative 4i, so that's equal to z squared plus 4. Now this side, you can also put it in the form of difference of squares. I can rewrite this as z minus 3 plus I times z minus 3 minus I. So this part here, I can rewrite that in this way. Now, this is difference of squares because I have something plus something times something minus something. So the result is z minus 3 squared minus I squared. And you should know how to do z minus 3 squared, and then the minus I squared becomes a plus 1. Just, I can do that for a second here, I suppose. Z minus 3 squared is the same as z squared minus 6z plus 9 plus 1. So that's this term, and then this term is going to be z squared plus 4. All right, and then you multiply those two together. Of course, the 9 and the 1 make 10, and then to multiply those two polynomials, you can just do it by hand. All right, so that's question 1. Question 2, compute the following and give the answer in rectangular form. The complex conjugate of this very complicated expression. Now, I put this 33 here on purpose to discourage you from trying to do this in rectangular form. With complex multiplication, it's always, always, always use polar form for multiplication. Now, if you don't like to do polar form because you don't like trigonometry, then that means that you'd better brush up on your trigonometry, because you need to know trigonometry if you're going to do any kind of math. A math major who doesn't know trigonometry is just not a math major. Now, you can substitute for, you can draw your own unit circle by remembering the real and imaginary plane. This is the real axis, and this is the imaginary axis. Okay, now where is I? I is up here, right? So what angle is this? This angle is 90 degrees or pi over 2. Square root of 3 minus I, where is that? Square root of 3 minus I is down here. Now you should recognize this is a special angle. This angle is pi over 6. Then square root of 2 minus square root of 2i is down here. What angle is that? Well, that's minus pi over 4. Okay, so you have all the angles just from looking at the unit circle. You should be able to do this. Again, I strongly encourage you to practice on your own if you're not able to do this. Right, now, if I do this in polar form, I have square root of 2 times cis of pi over 2. That's the first part. And then what's inside is square root of 3 minus I. So I don't know what the radius is, but I do know what the cis is. I know that that's cis of minus pi over 6 on the top. Okay. On the bottom, I know that that's cis of minus pi over 4. Now, what's the radius? Well, you can, to figure out the radius, it's going to be, let's see if I can do it in here, it's going to be the square root of square root of 3 squared, which is 3, plus square root of 1 squared, which is 1. So that's the radius. Pythagorean theorem, square root of the real part squared plus imaginary part squared. The same thing down here. Square root, well, the real part squared is 2, and the imaginary part squared is 2. So that's what we have here. And this is to the 33rd power. All right? So let's continue. Here we have square root of 2, cis pi over 2. Now, how are we going to reduce this? Well, fortunately, the two radiuses cancel. What a coincidence. Now, what do you do when you take the ratio of cis's? Well, you take one cis minus the other cis. So that's cis of minus pi over 6 minus pi over 4, so I'll put plus pi over 4. And that's to the 33rd power. Okay. Now, minus pi over 6 plus pi over 4, that turns out to be pi over 12. Right? So I have cis of pi over 12 to the 33rd power. What happens when you raise a cis to a power? Well, you multiply the angle. So this whole thing becomes cis of 33 pi over 12. Now you can rewrite that because you can write that as cis of 11 pi over 4. And that's what I have here. Cis pi over 2 times plus cis of 11 pi over 4. So I have square root of 2 cis pi over 2 times cis 11 pi over 4. Okay. What do I do when I multiply two cis's together? Well, I add the angle. So that's square root of 2 times the cis. Now let me write this as 2 pi over 4 plus 11 pi over 4. So that's cis of 13 pi over 4. Now, what is 13 pi over 4? Well, you should think of that as 3 pi plus pi over 4. So let me just write that. Okay, now where is cis of 3 pi plus pi over 4? Go back to your unit circle. 3 pi is where? 3 pi is pi, 2 pi, 3 pi. So 3 pi is here. 3 pi plus pi over 4 is over here. So in fact, cis of 3 pi plus pi over 4 is the same as cis of 5 pi over 4. So if I do this, this is the same as 5 pi over 4. Okay. All right, so I have, this is equal to the square root of 2 times the cis of 5 pi over 4. Okay. Now, so that's equal to the square root of 2. Now, what's cis of 5 pi over 4? Well, I have to take the cosine of 5 pi over 4 plus I times the sine of 5 pi over 4. Now, this is where you remember your unit circle is the cosine of 5 pi over 4 is square root of 2 over 2. And then here I'm going to have minus square root of 2 over 2i. So that's equal to, if I multiply this out, I'm going to get 1 minus I. Whoops, I'm sorry. The cosine, this should be a minus 1. I'm sorry, because it's in the third quadrant. You can see the real part is negative and the imaginary part is negative. So this should be a minus 1. No, I'm not done. I need to take the conjugate. And that's going to be equal to minus 1 plus I. And that's your answer. That's it.